scaling out and hardening, I'll say, microservice kind of architectures. So we help make that very easy for people to get going, adapt to be flexible in terms of adapting to their environments and their particular needs, but allowing them to give the control that they need as part of their particular applications. So today, in that kind of larger context, we're going to be talking about how customers or how people have been approaching debugging microservice applications. Most people find that as you scale that out to tens to hundreds of microservices, that understanding that system, debugging it is hard. So what if we could help people proactively discover issues, make them repeatable so that they can actually harden their system beforehand in a controlled environment, so that way the overall system would be much more resilient to failures overall. And that's the overall problem that we're going to be talking about today. So let's dig into the problem a little bit. As people have moved from monolithic applications, which tend to be single process or an application and a database, those applications could be complex, but the systems that are being dealt with, it's a relatively small space. So, the ability to debug that, the tool sets that have been built up over the years can deal with debugging into a single process and kind of handle the challenges of that space. Still can be quite challenging, but it's a problem that many companies have dealt with in the past. As we move to microservice architectures, there's a couple of dynamics that come into play. One, that you're taking the application and turning it into a highly distributed application. So now you have many computers running, you have many disk subsystems, you have the network running in between, potentially multiple networks running in between. So suddenly the surface area, the number of things that could fail, has increased dramatically in terms of your application, in terms of the interrelationships between the components. The other aspect of as people move to microservices, which is less of a technology issue, is that a lot of companies are adopting microservices to get speed, which means that they're building smaller teams that are less tightly coupled, which means they're spinning out new features quickly. They're not necessarily coordinating by design with each other as frequently. So you're getting a lot of new changes. You're not getting the same coordination that happened with a monolithic application. So again, a lot of new combinations that come into place, and that can dramatically increase the complexity of trying to understand and debug these systems. To give you a sense of the scale, if you look at like Netflix or Twitter, just the connectivity graphs between the hundreds of microservices is just unfathomable. I mean, you just can't even conceive of, what services are talking to what other services. So trying to say, hey, 3 of these 500 services are having an issue. Go figure that out. It's like, who are they talking to? What are the latencies? What are the other issues that are coming into play? So it becomes a real challenge for companies to adopt it. So there's a lot of benefits to microservices in terms of they're getting speed of new functionality, business functionality out there. Good, but there's a complexity trade-off that's coming with that. So now with any kind of a microservice deployment, if you have an outage, it's like a murder mystery. I'm trying to figure out, who did it, what room happened, what the weapon was. It's a challenge to kind of dig into that issue. And the tooling that exists today, a lot of static code analysis and debugging tools don't, they were built for sort of single application, single process deployments. So those don't help us in this kind of environment as much. There are some language specific. If we reference Netflix again, Netflix OSS built a lot of tooling around Java to help with circuit breaking, what happens if I can't connect to a service or retry, or so there are some libraries that exist for some languages, but as many corporations adopt multiple languages within these deployments, so I've got Java and Golang and JavaScript and Rust and other kinds of applications, even if those frameworks exist for those different environments, there's a challenge of they all do it slightly differently. So now, if you did it that way, now you're also kind of debugging what are the differences between these environments. And just the idea of if I'm trying to debug it, I've got to modify my code to go instrument it, to go figure that out. Now I'm probably doubling or tripling my deployments to try and deal with it. So all of these become a challenge. But there's hope. So Service Mesh, we believe, as part of its promise coming in, can help deal with this issue, as well as a lot of what came out of Netflix in particular is this concept of chaos engineering, where we can put some discipline around how do we test these complex environments to actually harden and make them more resilient. So we can put some discipline and best practices around this. So what does that mean? So chaos engineering is equivalent to, if you use an analogy of getting a flu shot, a vaccination. So the idea of a vaccination is I'm going to inject a person with a little bit of the virus or the allergen that I'm dealing with. And the body is great at creating antibodies when it detects that. So now your body, that because it sees a little bit of that virus, it suddenly builds up a lot of antibodies in response to that. So now it's ready. So if it really gets, exposed to that virus, now its defense systems are up. It's ready to attack it. The body is now more resilient to fighting that off. So vaccinations has proven to be a very, very good technique within humans of how to deal with that. We can take the same sort of approach to our networks, where we can intentionally, in a controlled fashion, inject faults into our network environment, into our highly distributed microservice environment, and analyze that and actually use that to help us harden the system out, so that we can figure out, how to make it better. And the reason that service meshes help us in particular is what's found out, again, through Netflix and other environments with the Netflix OSS code, is that people have found that they've combined in their applications sort of both the business logic as well as operational code. And by what do I mean by operational code is like retry logic, circuit breaking, service discovery, these kind of common things that were built into language-specific libraries. People have realized, and what service meshes have standardized on, is they've taken that code, pulled it out of language-specific frameworks, and put it into what most service meshes call this is a sidecar, a proxy. So it's proxy code that uses the network layer to communicate and to operate on that. So now you can pair your business logic up with these proxies so that you can get all of the same benefits of that operational code, the retry logic, discovery, circuit breaking, et cetera, but without having it tied to a specific logic or language in there. And that's a core benefit that pretty much every service mesh deploys out there. And this allows you to deal with, as your application topology changes, I deploy new services. Again, microservices is about speed. So as I deploy more of it, the service meshes can guarantee that those proxies with the operational code are automatically deployed, can deal with it at the time and speed that I need it, all language neutral, and I don't have to change my code. I can deploy policies to my service mesh to actually deal with the different changes. So I don't have to change my business logic code. I can use the operational tools that the mesh provides me to enact the changes. So we think the combination of these two, the sort of the discipline of chaos engineering, that vaccination kind of approach, plus service mesh, give you some real tools to deal with this complex environment. And this is where Gloo Shot comes into play. So we've created an open source project called Gloo Shot that leverages service mesh and allows you to create controlled experiments that you can run on your environment. So by controlled experiments, again, to abuse, to over talk about Netflix, there's other examples of this as well, but Netflix famously created a project called Chaos Monkey. The idea of it is that when Netflix had built out a large scale environment back in 2010, they were seeing intermittent process failures in their environment. So they created a tool called Chaos Monkey to intentionally create those process failures during the business day. So when the engineers were all there working, they increased the frequencies intentionally of these process failures so the engineers could actually see them, react to them, understand what was going on, and then actually address those issues and make it, fix it, as opposed to process failures happening at 2 in the morning on Saturday and everybody's got to get out of bed and try and figure that out. Gloo Shot takes the same approach. It allows you to create controlled experiments where you can introduce message delays, you can introduce faults, so you can have individual services return errors in a controlled fashion. So you can create this experiment, I can create certain error conditions in my environment, and I can create stop conditions so that if my experiment starts to get out of control, I can put, if it starts to cascade out, I can actually stop the experiment in a controlled way. And all throughout this whole thing, I can be capturing a lot of information around what was going on so I can actually understand how the system's working. And Gloo Shot layers on top of other projects called Superglue that deal with the recently announced service mesh interface process. This is a common interface that's being standardized by a number of companies led by Microsoft, but based on a lot of work that we've done within Superglue to provide a common interface to Istio, Linkerd, AppMesh, console, other service mesh interfaces, so you can have one way to automate this across many. So that's a lot there, but the idea and what we're going to demo in a second is what Scott's going to demo is the idea that you can create these experiments. So you can, if you're seeing issues currently in your microservice application, you can create experiments that reproduce those failures. So you can kind of run them when you want. Presumably when all your engineers are awake and watching their systems, you can create those experiments, generate higher frequencies in your production environments or in staging, so that you can see what those are, gather all the metrics, and also set stop conditions so that the chaos doesn't get completely out of control. And that's basically what Gloo Shot's trying to do, and that's what we're going to give you a little taste of today. Again, all of it's open source. You can try it out as you want. But with that, let me hand it over to Scott, and he'll show you this.
Thank you, Scott. Okay, so I will. Oh yes.
That way people can watch the wonderful stuff you're going to do.
Let's share. Sharing is a good place to start. All right. So what I'm going to do here is actually demonstrate a tutorial for you that is available online at our Gloo Shot docs. So you can try this on your local Minikube or GKE cluster. It's all designed to run on top of Kubernetes. So I will just jump right into the tutorial. I have my my terminal open here. So if I just show you my cluster, I have a clean cluster, hopefully, that just has the basic namespaces, and we will start from scratch. So all I've done on my side is installed the Gloo Shot and Superglue CLI. Gloo Shot leverages Superglue. Superglue, I won't get too deep into it, but essentially it's like an operator. If you're familiar with the Red Hat operator, the CoreOS operator, it basically automates different tasks such as installation, operation, provides that translation for SMI that Scott mentioned before. So it's essentially a component of Gloo Shot, but in two of them together allow you to use your mesh without having to directly interface with it. And we'll show you how that works. So the demo I'm going to show you involves the Istio book info example that we've modified slightly. But just to give you an example of a visual of what it looks like, We're going to visit a product page, which is mapped to two different services, a detail service and a review service. And the review service talks to the rating service. And the point of this experiment here is we're going to test our system against cascading failures. This is one of the issues that's very common in microservice architecture. You have some service that might go down, and we want to ensure it doesn't bring down our whole system. So we're going to run an experiment to verify that and see if we can make our system more resilient. So I'll just get started with deployment stuff. Let's install Gloo Shot into our system. This is going to register CRDs. So if you're familiar with like the standard Kubernetes way of interacting with an application, it's usually through the CRD level. So we see we have two different CRDs that are created here for Gloo Shot. One of them is called experiments. This is how we're going to actually run these controlled experiments, and reports, which are generated by Gloo Shot that give us some data after something is run. Then I will Gloo Shot init, which will actually deploy my Gloo Shot components to the cluster, which is all done from a Helm chart, but this just makes it a little easier. Sure. This is actually deploying a number of components. I'll show you here. Gloo Shot. So we can see it's installing Gloo Shot itself, which is the controller that watches CRDs, some discovery components, as well as Superglue and Prometheus. So the Prometheus we're going to use to monitor the results of the experiment, and Superglue is going to provide all that heavy lifting for us. These are all components. They're bundled with Gloo Shot out of the box. You can, of course, use your own Prometheus instance if you want, as well as if you're using Superglue separately, you can remove that from this deployment as well. But it's just easiest for us to have all of that together. So while that is starting, I will use Superglue to install a mesh to my cluster. I'm going to use Istio in this example. Superglue, one of the features that it provides is the installation of meshes. So I don't have to deal with Helm charts or YAML manifests to make sure everything gets done. I can just run a single command. This will actually create an install CRD, which Superglue will use to deploy Istio components. And we'll see shortly that all the Istio components come up online. Knock on wood. Should see everything gets going. And OK, so I just want to make sure that everything is running before I get to the next point in the tutorial. Let's make sure Gloo Shot is all happy. Why is this stuck in it? It's always something. All right, I'm going to restart this pod. I'm telling you that it's...
You weren't kind to the demo gods today.
Really. I literally was just working. OK. Restarting the pod.
That's a bonus of our webinar today, is you're going to see some live debugging as well.
Now we see that the new Gloo Shot pod is running. All right. So the next thing that we're going to do is we're actually going to have, so if I pull open, let me start at port forward here. Port forward to, we don't want that one. We want port, oops. Yes, we're going to start a port forward to Prometheus, and we will just show you, hold on. Oh. And I will show you that Prometheus right now has no Istio metrics. But when I run this command, the Superglue command, what it's going to do is it's going to wire my Prometheus to all the Istio sidecars. And pretty shortly, we should see those metrics become available. Just have to make sure our port forward is working. Sometimes the network gets a little spotty here. I'm running my cluster on Google. OK. And we may have to give Prometheus, it's already done it. So now we can see we have some metrics that Prometheus is getting from the Istio sidecars. Okay, this is a prerequisite for Gloo Shot working, because Gloo Shot actually will watch Prometheus in order to determine the outcome of the experiment. So now that we've done that, let's deploy an application inside our mesh. We're going to create a namespace and deploy this book info application there. We've labeled it with the Istio injection label, and so those pods should get, we'll watch the pods in the book info. Those pods will get injected. We could see that there's a second container on all of them, and they run this init container.
So that injection is the sidecar?
Yes, they're injected with the sidecar, which is talking to the Istio control plane. So now if we start a port forward, whoops, no, I had it open here. All right, so if we open our port forward, we can actually see the book info application, and it's sometimes this this pane takes a little bit of time to load just because the Istio sidecars are first getting their bootstrap configuration. Okay, so we hit refresh, and now if we hit refresh, hold on, oh, it looks like our port forward for Prometheus died. I'll bring that back. Now we can see by hitting refresh on the page a few times, we can see these some data being generated for Prometheus from those sidecars. One of the things you'll notice is when I hit refresh on the page, these stars cycle through. That's because the way the book info application works is it balances between, load balances between these three different versions of the service. So what I'm going to do now is I'm going to actually create, using Superglue, I'm going to create a routing rule that's going to force all the traffic to go through. You don't see it in this diagram, but we have a v4 of the service. So I'm going to send all the traffic there with the Superglue command. This is one of the features Superglue provides. This is also part of the SMI. This creates a CRD that tells Superglue, we can take a look. Hold on. It tells Superglue to take all the traffic that's destined for the book info reviews and send it to book info reviews v4. So if we hit refresh on the page here, we should now only see the red stars, no matter how many times I hit refresh. Going back, we can check out the data. We have some more requests. Great. So our whole system is set up fine. Now what we want to do is we want to actually create an experiment that's going to test the resiliency of this connection here. We want to know that if this rating service is giving errors, that the review service will be resilient. So let's run an experiment that's actually going to do that. I'm going to take this I'm going to create an experiment custom resource that has the following configuration. It's going to run for 600 seconds. During that time, it's going to create a fault injection using Istio. Istio will allow us to return 500 status codes for 100% of the requests sent to the rating service. Then, in the meantime, during this duration, we will watch a query that will take the rate of responses from reviews, the review service, and ensure that the percentage of requests never, of 500 response requests never goes over 1%. So
that's the stop condition for Gloo Shot?
Yes. So what Gloo Shot will do is it will run until either a failure condition is met or the duration elapses. If the duration elapses, the experiment is considered successful, but if a failure condition is met, it's considered to be a failure. So let's just create that CRD. And immediately, when we hit refresh, we should see now that the reviews service is down. So our service is not resilient. It's not behaving well under these conditions. If we keep refreshing, we should see pretty quickly that the fault has been removed and Gloo Shot ended the experiment. So it's restored everything to its previous state. And if we get the experiment, we can actually see, hold on, this is the wrong name. we can see that a result was reported that has a failure report, and it gives us the percent. So it observed 23% of requests failing within a minute, and it decided to stop the experiment. So going back to our tutorial, we can also see there's a report that gets generated. If you want deeper insight into what's going on, it'll show actually each observed value during the period where it's polling Prometheus. So now what we'll do is we will try a more resilient version of the app. We already have this deployed. Instead of having to go through the whole deployment process, I will simply create a new routing rule that routes traffic to this alternate version of the service, this v3. So going back, we can just test. This also has red stars, so we can assume that the traffic shifting rule was created properly. Now let's go and run a new experiment. So we'll run basically the same experiment this time, but this time it's only got a duration of 30 seconds. So we can verify in a reasonable amount of time. So we've created this experiment, and when we refresh the page, we can now see that the rating service is unavailable, but the review service is still working. So very happy, everything looking good. We can now verify that our system has become more resilient against cascading failures. We run the query here, which maybe would have been more interesting when there actually were 500s being returned, but we can actually put this query directly into Prometheus. And right, so we can see here in the past where the failure rate went very high, but now when we refresh the page,
so that was our first experiment where that spike is showing.
Yes, that's right. Now the second experiment, there is no 500 because our new version of the service is failure resistant. So the 30 seconds have elapsed, and we can see now that the experiment was the failure condition was removed. And if we get the experiment, we can see that it was marked as having succeeded. So in this way, using Superglue and Gloo Shot, you can essentially automate the tasks, the low-level tasks that you could accomplish with a service mesh without having to directly interact with it. You can focus on high-level concerns such as chaos engineering without having to get into the nitty-gritty of the service mesh management itself. And with that, I'll hand it back to Scott.
Cool. I guess Betty will switch back to Q&A.
Yeah, so if you could go back to that last slide. So folks, thanks for joining today. And here are some great links for getting started with Gloo Shot. You know, Scott Weiss in the demo did show Superglue, which is an orchestration project for Service Mesh. However, we also have Service Mesh Hub if you wanted to use a GUI-based dashboard in order to install your Service Mesh. And I believe Gloo Shot is also there, so you can have like a point-and-click download. So link to documentation, so you can see some of the screens that Scott was sharing. And if you're interested in, you know, this is an open source project, so if you're interested in participating, contributing, you know, we have our GitHub link there, and we can continue the discussion after the webinar in the community Slack. So those are all links that you guys can go to continue this conversation. So right now, if there's any additional questions, please pop them into the Q&A window. I'm going to start with the few that we have here. You know, just as a recap, what kind of experiments can people run with Gloo Shot? Like what categories or types of experiments?
Okay.
Yeah.
Sure. So there are two groups of experiments that we support right now. You can inject failures. So essentially have failure codes returned when one service tries to reach another service. That can be an in-cluster microservice or something running outside of your cluster, like in a third-party service. And you can tell those things to return 404s, 500s. You can decide what the response is. And so the proxy will directly send a response. The other thing you can inject are delays. So you can inject essentially latency to use that to test the latency issues in your network.
And then one question here is, if you don't have a service mesh set up yet, can you still use Gloo Shot?
So I think part of the point with Superglue and Gloo Shot is to extract that from you, so it becomes just another installation dependency. However, Gloo Shot does require running a service mesh. That's where you're able to do these changes via configuration rather than having to modify the code in your application.
A follow-up question here. Are there other types of experiments and things that we have published on our roadmap in the GitHub repo? Any other things planned that we're able to talk about at this time?
So we've built sort of analogous to Gloo Shot. We've which we showed at KubeCon. We've got an analogous technology called Loop that works with a debugger that we've built for the last year or so called Squash. So what Loop does is similar to Gloo Shot. So Loop will actually watch as request traffic is going through, multiple services as part of, generating a response for a particular user. Loop can capture all of the request information, response, metrics on these particular services. And so that if everything is going well, if everything is working, Loop will just throw away that information. But if one of the responses hits an error condition, so something bad happens, and you can define what bad means, Loop will capture all of the statistics and all of the requests, the full request, the header, body, everything of all of the messages through that response. So then you can debug that. You can take that information, apply it to a different cluster. Generally, you don't want to do debugging in your production environment, as in hit breakpoints and stop services outright. So you can go to, say, a staging or a separate cluster and replay with the same information that caused the fault. You can replay that request and then use Squash to actually do full live debugging of your services with the information that actually caused the issue. So now you can try and understand what went wrong.
That's a good point. You have that.
Sorry?
Yeah. Oh, no, I was going to say that's a good point on how we kind of showcase that an early preview at KubeCon. We can send, as part of the follow-up to this webinar, we can send the link to that recording to see the Loop demo.
Yep, absolutely.
And then actually, Scott, you brought up a good point, because the next question was, if I find a problem by running an experiment, do you also help me troubleshoot and fix the issue that we discovered?
Yeah, and that's where Loop and Squash kind of fit into that whole equation. So you can use the combination of these two. So Gloo Shot, you can actually do experiments to figure out where there may be challenges in your environment, or to use it if you're seeing production issues. You can use that to make them more reproducible, and gather information about, like the first demo that Scott showed in terms of the cascading failures. So you can understand, okay, if the rating service is out, it's actually going to cause my review service, or the other way around, to have issues. So you can use Gloo Shot to actually gather a lot of information, and then you can use tools like Loop and Squash to actually dig into the code itself to try and understand how to make that system much more resilient. And there's certainly more technologies coming along with Service Mesh Hub in particular. We're building out a whole extension ecosystem around this. So we're seeing a lot of other very interesting technologies that take advantage of service meshes to do things like canary deployments and other things as well. So we're very excited about the potential. Once service meshes are out there, there's lots of exciting things you can do on top of that will make it much easier for customers to build out large scale networks, that are highly resilient, delivering lots of business value.
Let's see here. And last question here. Does Gloo Shot have any intelligence to help manage the routing?
It's a question of what we mean here by managing routing. Gloo Shot itself is specifically focused on the fault injection features. So it's not going to do, I did demonstrate some routing features. Those are part of Superglue. If you wanted to do intelligent routing and integrate Gloo Shot, for example, you wanted to like watch Prometheus metrics and based on failure rates, you know, have reactive routing. That's something you could do. It would probably require writing a little bit of code, like a controller, to watch those different things. So Gloo Shot is a component in that system, but I wouldn't say Gloo Shot itself is managing routing.
Yeah, so that's a good segue to say that Superglue as the open source orchestration component, or is the area that in which the routing across the services in the mesh would happen, right?
I also see a question here about whether Loop only works for RESTful services. It'll actually work for any HTTP service. So that's gRPC, SOAP, as long as the communication is on is in HTTP, it shouldn't be a problem to record and replay that.
Great. So it looks like that's all the questions we have today. Thanks everyone for joining, and thanks for all the questions. We'll have the recording. We'll have the recording out to everybody shortly. And see you at the next webinar. Thank you.
Thank you.
Thanks.